Hey everyone, welcome back to Syntax Grid. In this video, we're covering one of the most essential topics in data science, descriptive statistics. So grab a notebook and let's dive in. 1. Mean, median, mode. What are they? Descriptive statistics begin with measures of central tendency. They tell us about the center or typical value in a dataset. The three main metrics are mean, median, mode. Mean. The arithmetic average. The mean considers all values, so it gets easily affected by extremely high or low numbers, called outliers. Median. The middle value when data is sorted. The median is more stable in such situations. It finds the middle, so even if few extreme values sneak in, it stays reliable. Mode. The most frequent value. The mode is different. It focuses on frequency, so it tells you what's most common rather than the average. Now let's head into code and see how these metrics behave in action. We'll check two examples, one simple and one with an outlier. Example 1. Simple case. In this dataset, the mean and median are pretty close, around 28 to 30. The mode is 20, since it appears twice, a nicely balanced set. Example 2. With outlier. Now, look at how the mean shoots up because of that big number 50. But the median stays at 8, giving a much better sense of center. That's why we often trust the median more when the data is skewed. 2. Standard deviation and variance. Once we know the center, we need to understand how spread out our data is. This is where dispersion metrics come in, especially variance and standard deviation. Variance shows how far each number is from the mean, on average. Standard deviation is just the square root of variance, bringing it back to the original scale of the data. Think of variance as how scattered your data points are. If most values are close to the mean, the variance will be small, but if they're spread far and wide, the variance and standard deviation will be high. Standard deviation is just an easier to interpret version of variance. Same story, but with more understandable units. Let's now explore these concepts through code. Example 1. Low variance dataset. These values are clustered near 10. So, the spread is minimal, and both variance and standard deviation are low. Example 2. High variance dataset. Now we've got numbers like 2 and 30. The spread is big, and that's exactly what variance and standard deviation reflect. 3. Range. The range is the simplest measure spread. It's just the difference between the highest and lowest values in your dataset. While easy to calculate, the range can be misleading. Why? Because it only looks at the two extreme values. If there's an outlier, like a huge number far from the rest, it can make the range seem larger than it really is. Let's try it out and see. Example 1. Tight range, from 4 to 8. That's just a range of 4. Pretty tight. Example 2. Wide range. Now, the highest is 100 and the lowest is 1, a much wider spread. But again, it doesn't tell us how the values in between behave. 4. Boxplots. A boxplot is a graphical summary of 5 key numbers: minimum, first quartile Q1, median, third quartile Q3, maximum. And most importantly, it visually marks outliers. Boxplots divide your data into 4 equal parts. The box itself shows the middle 50% of the data. The line inside is the median, and the whiskers stretch to the min and max, unless there are outliers. Any point that falls far outside the range is flagged as an outlier. Let's draw 2 box plots and interpret them. Example 1. Symmetrical box plot. This plot looks neat and centered, suggesting a symmetric distribution. Example 2. With outlier. That 90 stands out, literally. The box plot marks it as an outlier, giving you quick insight into anomalies in your data. 5. Histogram. Histogram is a bar chart that shows how frequently data points fall into certain ranges, called bins. Imagine cutting your data into chunks. For example, ages 0, 10, 10, 20, and so on. Then, count how many values fall into each chunk. That's what a histogram does, and it helps reveal the shape of your data. Is it normal, skewed, bimodal? Let's create 2 histograms and observe. Example 1. Normal distribution. This one gives a bell-shaped curve, a classic normal distribution. Example 2. Right-skewed distribution. Here, most data is on the left, but a few large values pull the distribution to the right. A right-skewed pattern. Descriptive statistics are just the beginning when it comes to understanding data. Next, we'll dive into inferential statistics, where we make predictions and inferences about a population based on sample data. Plus, stay tuned for some common interview questions related to statistics in data science, because knowing how to apply these concepts is key in the real world. If you found this breakdown useful, hit like, subscribe to Syntax Grid, and drop your favorite statistical method in the comments below. See you in the next one. And as always, happy analyzing!